Hello, so this is a revision video for AP Chemistry 9.1, Entropy Introduction. Entropy is often described as a measure of disorder in a system. In this context, disorder refers to the number of possible microstates, the different ways the energy of a system can be arranged at the particle level. A greater number of arrangements or greater molecular disorder corresponds to higher entropy. During chemical or physical changes, the entropy of a system often changes as particles get rearranged and energy becomes more or less dispersed. This entropy change is often represented as delta S. Entropy increases when particles gain more freedom of movement, meaning entropy change occurs when a substance changes physical state. For example, for a given amount of substance, a solid has a lower entropy than a liquid, and a liquid has a lower entropy than a gas. For example, when 1 mole of solid ice melts to liquid and then turns to a gas, the entropy of the system increases. At constant temperature, the volume of a gas impacts the entropy of the system. Increasing the volume of the gas means gas molecules have more space to move, and this means entropy increases, positive delta S. Equally, decrease in volume means gas molecules have less space to move, and there's more order in the system, meaning entropy decreases, negative delta S. Reactions that produce more gas particles typically have a positive entropy change, positive delta S, while those that cause a decrease in the number of gas particles present have a negative entropy change, negative delta S. For example, when solid magnesium reacts with chlorine gas, the total moles of particles decrease from 2 to 1, and more specifically, the moles of gas decrease from 1 to 0, meaning a decrease in entropy, negative delta S. According to the kinetic molecular theory, KMT, covered in topic 5.5, entropy increases with temperature because energy becomes more widely dispersed among particles. As temperature increases, particles gain kinetic energy and move faster. This leads to a broader distribution of molecular energies as shown in Maxwell-Boltzmann distribution curves. The wider spread of energy amongst particles means the disorder increases, resulting in a greater entropy. So entropy increases with temperature. Entropy is quite a strange idea to understand and is ultimately a mathematical idea, meaning explanations often seem a little bit confusing. For study at this level, however, entropy is usually just referred to as a measure of disorder.